Hello everyone, welcome back to my channel Amit Math. My name is Amit Gupta. I have completed my B.Sc Math, M.Sc Math and B.Ed. I am also qualified CTET paper 2 and I have worked as a subject matter expert on Check India Private Limited where I solve advanced mathematical problems and enhance mathematical skill of the students. And also with having 3 years experience in this field of teachings. So our today topic is class 12 math vector algebra complete solution of exercise 10.4 which is based on NCERT pattern and one shot complete exercise of exercise 10.4. So we will solve in detail step by step solution with important concepts. In previous lecture we can study about all the theory of exercise 10.4. If you not watch it, please watch it, then proceed with this lecture. Okay, so we will begin it. So we will revise which we discussed in previous lectures. So if vector A equal to A1 I cap, A2 j cap plus A3 k cap and vector B equal to B1 I cap plus B2 j cap plus B3 k cap, then how to find B A cross B? We find A cross B vector which is I cap, j cap, k cap in determinant of and taking the coefficient of first vector because vector is first, then A1 I2 A3 component here and B1 vector B component B1 B2 B3. Okay, I hope it is clear. And finding the determinant this, so you get the A cross B. And second is by definitions A cross B is equal to modulus of vector A modulus of vector B sin theta n cap, where n cap is a unit vector perpendicular to A and B and theta is the angle between vector A and vector B. Since n cap is a unit vector, so modulus of n cap becomes 1. And if we need to find unit vector perpendicular to vector A cross B, vector A and B, so we need to find this n cap is equal to plus minus of vector A cross B upon modulus of vector A cross B. Okay, so where plus saying that in these directions, so, okay, this is vector A and this is vector B. Okay, and the angle between them is theta. This is n cap here. Okay, and negative directions is here. This is minus n cap. Okay, so this is both are perpendicular vector A and B, so we taking the plus minus here. So I hope it is clear to you. A modulus of vector A cross B, if taking the modulus of this and theta with the equivalent angle, then modulus of sin theta becomes sin theta. So modulus of vector A, modulus of vector B sin theta. Okay, and fourth is vector A dot vector B whole square equal to plus modulus of vector A cross B whole square equal to modulus of vector A whole square modulus of vector B whole square. This is very important formula. Okay, and fifth is A cross B equal to minus B cross A. Here you see that the commutative law does not follow in vector multiplication. So vector A cross B equal to minus vector B cross A. And 6 is if we multiplied taking vector product of vector by itself, so it becomes vector 0 because it's making angle theta equal to 0 because every vector are parallel to itself, so it becomes vector 0. Area of triangle ABC is what? Half modulus of AB cross AC. We're taking any two sides adjacent side like AB cross AC, like BA cross BC, like CA cross CB. Okay, so taking any two sides adjacent sides, and area of parallelogram adjacent sides are vector A and vector B. We're taking the A cross B modulus. Okay, this is in square units. This is all about which we discussed in previous lectures. So coming to the next. So exercise 10.4 here, this is based on NCERT pattern. Question number 1, we need to find modulus of vector A cross B if vector A equal to this and vector B equal to this. So simplified solution. First we find vector A cross vector B. So solve vector A cross vector B. So we write it in the determinant format. Here I cap and j cap and k cap. Okay, and we need to write component of vector A first because vector A is first in A cross B. So we write component of I cap j cap here. This is 1. Coefficient of j cap, this is minus 7. Coefficient of k cap, this is plus 7. And we write component of vector B in this I cap coefficient equal to 3. So we write in I cap columns and j cap coefficient is minus 2. This is minus 2 and k cap coefficient is 2. Just simplify. This is plus minus plus. This is only determinant of 3 cross 3 which we are already told in determinant chapters. Okay, so solve it along R1. So this is plus, so I cap. Okay, and take removing first row and first column, you get minus 7. You get, I like here, suppose this is what you get minus 7 minus 2 and 7 and 2, and here minus j cap, so minus j cap, and taking, so removing second column and first row, you get 1 3 7 and 2, and this is a plus k cap, yes, removing first row and third column, so you get 1 minus 7 3 and 2. You already know that solving ABCD up to class 2 determinant like A into D minus B into C. So this is a solving method of 2 cross 2 determinants. So simplify it as like that. A cross B is equal to, this is I cap, say minus 7 into 2, this is becomes what? Minus 14. So, minus 2 into 7 minus 14, minus minus plus 14 years. Okay. So I hope it is clear to you. 1 minus 7 7, 3 minus 2 2. Okay, ठीक. Simplified. So minus j cap is 2 into 1 2, 3 into 7 21, okay, plus 2 into 1 3 into 7 plus k cap, this is 2 1 2, plus minus minus of 3 into minus 7 minus 21, so we write it here. So a cross b, what? A cross b becomes minus 14 plus 14 becomes 0 y cap, 2 into minus 29 becomes minus 19, minus 19 j cap, and this is here's k cap, and 2 plus 21, this is 2 plus 21, simplified, you get what? A cross b, you get 0 i cap plus 19 j cap plus 23 k cap. Okay, so simplified, you get modulus of vector A cross b. This is simply what? Component of I cap j cap whole square and summing them. This is 0 whole square plus 19 whole square plus 23 whole square. Simplified, you get modulus of vector A cross b. So simplified, so what we get? This is 0, 19 whole square 361, and 23 whole square 529. So adding them, you get what? 910, okay, and 269, 268 and carry 1 9s, okay, and 538 and 538 you get here. This is 9 110 and 268 and it carry 1 becomes 9. This is 538 under root 890. Okay, so this is 1 minus 7 7, 3 minus 2 2. This is okay. This is correct. Checking it. Okay. Okay, clear. I hope it is clear to you. This is under root 890. So we write as modulus of vector A cross B is equal to what? Under root 890. So this is our answer. I hope it is clear to you. This is our answers. Clear? I hope it is clear to you. So coming to the next. So this is find the unit vector perpendicular to each of the vectors here. So solution is what? We need to find the unit vector perpendicular to each vector. Let vector C is equal to vector A plus vector B. So what is this? Vector A is here. So 3i cap plus 2j cap plus 2k cap. Okay, this is vector A and this is vector B. This is I cap plus 2j cap minus 2k cap. So finding them, it's just adding 3i cap plus I cap becomes 4i cap, and 2j cap becomes 4k cap. Okay, and 2k cap minus 2k cap becomes 0k cap. So vector D what? Vector A minus vector B, and let vector C equal to vector A plus B and vector D equal to what? Vector A minus vector B. Simplified. This just solve 3i cap minus I cap becomes 2i cap, and 2j cap minus 2j cap becomes 0j cap, and 2k cap minus 2k cap becomes 2k cap minus 2k minus minus plus, this is becomes 4k cap. Okay, so simplified. Okay, and we need to find unit vector perpendicular to vector C, and this is vector C and this is vector D. So therefore unit vector perpendicular to vector C, and vector C is what? Vector A plus B. Vector D is equal to what? Vector A minus vector B. Vector D is equal to what? plus minus of vector C cross vector D upon modulus of C cross D. So in order to find, suppose this is n cap, so solving it, C cross D and modulus of C cross D, so we can find C cross D here. So writing here, so this is I cap, J cap, K cap, and taking the component of vector C here. So what is component of vector C? 4 4 0. This is a 4 4 and 0. Okay, so what is component of D? Vector D 2 0 4 2 0 4 2 0 4. Simplified, this is a plus minus plus. We simplified direct here. So along R1, this is I cap. For removing first row, first column, 4 into 4, 16, 0 into 0 0, minus J of cap, and removing second column, first row, you get 4 into 4, 16, 2 into 0 0, plus K cap. Removing third column and first row, you get 0 into 4 0, and 2 into 4 8, minus 8, you get this. So vector C cross vector D, what? Vector C cross vector D becomes 16 I cap minus 16 J cap minus 8 K cap. So this is, we're taking modulus of vector C cross D, it becomes this is 16 square minus 16 whole square minus 8 whole square. Simplifying it, you get the answers. This is 256 minus 16 is whole square plus 256 and 8 whole square, this is equal to 64. Simplifying here, so see on your screens, its modulus of vector C cross D, it looks like this. 256 becomes 512 plus 64, adding you get these answers. 426 and 426 and 617 and it 576, it equal to 24 whole square, it equal to 24 whole square. So modulus of vector C cross vector D, we get simply 24. So what we need to find? So n cap. So using n cap here, taking another slide. So this is n cap. N cap is what? Perpendicular to vector C and D. This is plus minus of vector C cross vector D upon modulus of vector C cross D. So we can simplify it, plus minus here. And what is this? And this is vector C cross D, 16 I cap minus 16 J cap minus 8 K cap. So once again, 16 I cap minus 16 J cap minus 8 K cap, and this is modulus of vector C cross D, what? This is a 24. Simplifying it, n cap is equal to, taking a common 8 from numerator, this is plus minus 8, this is 2I cap minus 2J cap, this is minus K cap upon 24. Okay, 8 3 are 24. So it becomes, looks like plus minus 1 by 3 2I cap minus 2J cap minus K cap. This is the unit vector perpendicular to vector A plus B and vector A minus B, vector A plus B, vector C. So this is our answer. This is what? Plus minus 1 by 3 2I cap minus 2J cap minus K cap. This is our answer. Okay, so this is our answers. I hope it is clear to you. Solving the next. If a unit vector makes angle pi by 3 with I cap, pi by 4 with J cap, and equate angle theta with K cap, then find the theta and component of vector A. So solution is here. Let vector A equal to A1 I cap, A2 J cap, and A3 K cap. Okay, so and it is a unit vector, so modulus of vector A is equal to 0, also 1. Since this is a unit vector, so and taking the modulus, you get what? A1 square plus A2 square plus A3 square equal to 1. It means that A1 square plus A2 square plus A3 square equal to 1. Now let equation number 1. And also according to question saying that what? A unit vector A makes angle pi by 3 with I cap. So taking the dot product of vector A dot I cap. Vector A dot B is equal to modulus of vector A, modulus of vector B cos theta. So taking the modulus of vector A, modulus of I cap, and cos of what? What is the angle between them? A vector A and I cap. Here saying that pi by 3. So this is cos pi by 3. Simplifying it. So vector A dot I, taking the vector A dot I here, vector A is equal to what? A1 I cap, A2 J cap, A3 K cap. So I cap simply write as 1 into I cap plus 0 into J cap plus 0 into K cap. Okay, and this is modulus of vector equal to what? 1. Modulus of I, because this is a unit vector along axis, so this is 1. Cos pi by 3 equal to what? 1 by 2. Simplifying it, you get this. And multiplying here, you get A1 I cap 1 and A2 into 0, 0 into A2 plus 0 into A3. You get 1 by 2. You get what? A1 plus 0 plus 0. 1 by 2. So A1 equal to what? A1 equal to, we get 1 by 2. Okay. Similarly, we solve it. Similarly, okay, similarly what? It is saying that pi by 4 with J cap. A vector A make angle with J cap pi by 4. So taking the dot product vector A dot vector J, it's equal to modulus of vector A, modulus of J cap, and cos what with J cap pi by 4, cos pi by 4. Just simplifying it. I will be simplifying here. So every coefficient of A1 A3 becomes 0, A2 into J cap becomes A2. If we solve vector A dot J cap, it becomes A2. So modulus of vector A1, this is 1, and cos pi by 4 is equal to 1 by root 4. A2 is equal to what? 1 by root 2. I hope it is clear to you. This is 1 by root 2. Similarly, it is saying that this is making an angle theta with K cap. Okay, so also, and similarly vector A dot K cap is equal to modulus of vector A, modulus of K cap, cos of, saying that theta with the angle, and this is equate angle, so theta lies between 0 to pi by 2. So this is equate angle here. So simplifying it, it becomes what? It becomes A3, and this is 1 into 1, this is a cos of theta. So A3 is equal to what? Cos of theta. Okay, so A3 equal to what? Cos of theta. I hope it is clear to you. From equation 1, what is equation 1? A1 square plus A2 square plus A3 square equal to 1. Now from 1, A1 square plus A2 square plus A3 square, simply 1. So this is here A1 equal to 1 by 2. So A1 equal to what? 1 by 2 whole square, and A2 is equal to what? We simplify as 1 by root 2. So this is 1 by root 2 whole square. 1 by root 2 whole square. So A3 is what? Cos theta, cos square theta. This is equal to 1. Simplify it. 1 by 2 whole square, 1 by 4, 1 by root 2 whole square, 1 by 2. This is the cos square of theta is equal to 1. Simplifying it, here 4 is LCM, so 4 1 is 4 and 2 2 is 4. This is 2 plus cos square theta. This is equal to 1. Simplify it, you get the answers. So if you be simplifying, you get 1 plus 2 3 plus cos square theta is equal to 1. Then cos square theta is equal to what? 1 minus 3 by 4. If you solve, this is 4, this is 1, and this is 4 minus 3. You get 1 by 4. If you taking the cos theta is equal to what? 1 by under root 1 by 4. Because theta is the equate angle, so we line first quadrant. This is 1 by plus 1 by 2. Taking not minus 1 by 2 because it is lying first quadrant. So this is cos theta. Cos theta is equal to what? 1 by 2, and from this you get A3. If you find the angle, then cos theta is equal to what? 1 by 2. This is equal to what? Cos pi by 3. So simplifying, theta becomes what? Pi by 3. And this is a equate angle. Theta equal to pi by 3. I hope it is clear to you. So what we need to find? So we need to find what? we need to find angle theta. It is lies in first quadrant because this is equate angle, and component of vector A. So component of vector A what? Scalar component A1 A2 A3. So we write as component of vector A what? Component of vector A, scalar component what? A1 A2 A3. So we write as what is value of A1? We find already here. What is A1? 1 by 2, A2 1 by root 2. So A1 is equal to 1 by 2 and A2 is equal to 1 by root 2 and A3 is equal to what? 1 by 2. So this is our answers, and theta is equal to what? Pi by 3. I hope it is clear to you. So this is all about. Okay, this is all about these questions. First, we write a vector A and taking its component A1, A2, A3, and just this is saying unit vector. So this is satisfy the unit vector property. So we A1 square plus A2 square plus A3 square and the root equal to 1. It's squaring on both sides, we get this. So this is making angle theta with I cap pi by 3. So we satisfy this equation. So A vector A dot I cap and multiply just looking like A1 equal to 1 by 2. Okay, so we simplify A1 equal to 1 by 2, and similarly we got A2 equal to 1 by root 2 because saying that this vector making with a j cap pi by 4 angle. So it's satisfy this dot product. So using this you get A2 equal to 1 by root 2. Similarly, you taking the component of k cap because this is making angle theta. So we writing as here theta, cos theta, taking the modulus of each and satisfying the dot product. So A3 becomes cos of theta. And how to find A3? We just from equation 1, just putting A1, A2, A3, you get this. Cos square theta becomes 1 by 4 and cos theta becomes 1 by 2. Not taking plus minus because theta is lying in first quadrant, so it will be positive. So cos theta equal to 1 by this is equal to A3. So we find as A3 cos theta equal to 1 by 2. So this is cos theta 1 by 2, cos pi by 3 and theta equal to pi by 3. This is all about the questions. I hope it is clear to you. Come into the next questions. So we need to show that this now proof. So we proceed from left hand side. Vector A minus vector B cross vector A plus vector B. Okay, since this is not a scalar algebra, so we don't use as like that. Vector A minus vector B cross vector A plus vector B. Not right as modulus of vector A whole square minus modulus of vector B whole square. Okay, this is incorrect because this is a vector. So it is solving vector A cross vector A here. Okay, and this is vector A plus vector A cross vector B. Okay, this is taking minus plus minus vector B cross vector A. Here order is very important. So minus plus, this is also minus vector B cross vector B, and you already know that A cross vector A is always equal to vector 0. Vector B cross vector B is always equal to 0, vector 0. Okay, because making angle with itself 0 degree, so it becomes vector 0. So what is vector A cross B is equal to minus of vector B cross A. We already told in the previous lectures. So if you want not watch previous lecture, please watch it and proceed with these lectures. So this is vector A cross vector B. This becomes 0. So vector A cross vector B and minus vector B cross A can be written as plus vector A cross B. So this is plus vector A cross B, and minus vector B cross B becomes vector 0. So this is vector 0, vector minus vector 0 should be becomes vector 0, and be adding any vector with 0 vector, it becomes like as vectors here. Like this is vector A cross vector B, this is vector A cross B. We common 1 and we common vector A cross B in both the terms. This is looks like as, so 1 plus 1 becomes what? 2 of vector A cross vector B. I hope it is clear to you. So this is right hand side, this is the right hand side, hence proof. It says that LHS equal to what? RHS. So we write as hence proof. Okay, I hope it is clear to you. First we know that the vector product of by any vector by itself equal to vector 0, and vector A cross B equal to minus vector B cross A. Means if you changing the order, it's taking the minus signs here. So this is all about this. And question number 5 is find the lambda and mu. This is 2 I cap plus j cap plus 27 k cap cross of I cap say lambda j cap plus mu k cap equal to vector 0. So solution is what? just taking the determinant format here. So this is I cap, j cap and k cap, and component of this vector first write 2, 6 and 27, and component of this vector what, 1 and lambda and mu. Simplifying it, this is equal to vector 0. This is vector 0 can be written as 0 I cap, 0 j cap and 0 k cap. Okay, so this is vector 0. So simplifying it, this is a plus minus plus. Simplifying it, this is I cap, removing first row, first column is 6 mu, 6 mu minus 27 into lambda minus j cap. Here you get what, this is 2 mu minus 27. Okay, 2 mu minus 27 plus k cap. You get what, removing third row, third column and first row, you get 2 into lambda minus 6, 2 into lambda minus 6. This is equal to 0 I cap, 0 j cap and 0 k cap. Okay, so simplifying it, this is I cap into 6 mu minus 27 into lambda, and if you multiplying minus in this, you get plus j cap. It becomes minus 2 mu plus 27. Okay, and this is plus k, and 2 lambda minus 6 is equal to 0 I cap plus 0 j cap and 0 k cap. Okay, so simplifying from this here, and here its component is because both vectors are equal vectors, so its component are also equal. Taking this and this 0 j cap here and j cap here, so coefficient of j cap here 0, here 2 minus 2 plus 27. So this implies minus 2 mu plus 27 equal to 0. You get 27 is equal to 2 times of the mu, and mu is equal to what, 27 by 2. And here taking the its coefficient k cap, its coefficient k cap equal to what, 0 here. So here 2 lambda minus 6, 2 lambda minus 6 is equal to 0. You get 2 lambda equal to 6, you get lambda equal to 6 by 2. You get 6, 2 3 is 6, so lambda equal to what, 3. So we find lambda and mu, and if you take in this, you get equation in mu and lambda. Okay, so then again for you have to solve it. So we taking only coefficient of j cap, k cap here. So answer is what, answer is equal to lambda equal to 3 and mu is equal to what, 27 by 2. This is by what, this is by equality of vector. This is by equality of vector, equality of vectors. I hope it is clear. So what is equality of vectors? A1 I cap, A2 j cap, A3 k cap. If vector this is equal to B1 I cap, B2 j cap, B3 k cap. If both are equal vectors, it only possible its component are equal. If A1 equal to B1, A2 equal to B2, okay, and A3 equal to B3. This is equality of vector. This concept is used here. Okay, so this is concept used here. So this is answer our. Coming to the next. Given that vector A dot B equal to 0 and vector A cross vector B becomes 0 vector, what can you conclude about the vectors A and vector B? So solution is what? So solution, we know that we already told about this formula. If vector A dot vector B whole square plus modulus of vector A cross B whole square is equal to modulus of vector A whole square modulus of vector B whole square. Okay, so if we solving this, given that what, A cross B is equal to 0 vectors, so its modulus is equal to what, so its modulus of vector A cross B becomes 0. Okay, because this is vector 0, and substitute this value here. So this is 0, so 0 whole square, and taking the modulus of it becomes 0, and modulus of vector A whole square equal to modulus of vector B whole square. So modulus of vector A whole square and modulus of vector B whole square is equal to 0, and this means that modulus of vector A and modulus of vector B is equal to 0. So this implies the modulus of two vectors, product of modulus of two vectors becomes 0. It is only possible if modulus of vector A equal to 0 or modulus of vector B equal to 0. Okay, and also we write vector A 0 vector or vector B 0 vector. It is possible only if vector A and vector B both are either vector A 0 or either vector B 0. Okay, so this is we write as this conclusion we write from this given statement, because theta is not dependency, because both vector A dot B equal to 0 and vector A cross vector B equal to 0 using this formula here. So we write as what? Either vector A0 or vector B0 and modulus of vector A0 or, so answer is what? Answer is write as here either vector A 0 vector or vector B 0 vector, or either modulus of vector A0 or modulus of vector B0. We write as both. So let's come to the next question. Here see that let the vector ABC A1 I cap A2 J cap plus A3 K cap B1 I cap B2 J cap plus B3 K cap and C1 I cap C2 J cap plus C3 K cap, then show that vector A cross vector B plus C equal to vector A cross vector B plus vector A cross C. We need to prove it. So prove it. So prove it. Taking the left hand side here. This is vector A cross vector B plus C. So summing them vector A, here saying that vector A equal to what? A1 I cap A2 J cap plus A3 K cap, and vector B equal to what? B1 I cap B2 J cap and B3 K cap, and vector C equal to what? C1 I cap C2 J cap and C3 K cap. So just simplify it. This is vector A. What? This is A1 I cap A2 J cap A3 K cap. This is a cross product of this. So taking vector B plus C here. So we taking vector B plus C, you get what? B1 plus C1 I cap. So this is B1 plus C1 I cap B2 plus C2 K cap and B3 plus C3 K cap. If we adding them, you get, okay. So we write as in determinant format as I cap, J cap and K cap. Okay. Sorry. So I cap component is here A1, A2, A3 component of this vector, and component of this vector what? B1 plus C1, B2 plus C2 and B3 plus C3. Okay, and you know that if this we write as this in the format of here I cap, J cap and K cap. This is the property of the determinant. Okay, we write as here in third row we're taking C1, C2, C3. So we write as I cap, J cap and K cap, and here A1, A2, A3, A1, A2, A3, and here what? A1, A2, A3. Okay, and here what? B1, B2, B3, and this is C1, C1, C2, C3. By what? By property of determinant. By property of determinant. Okay, this is property of determinant. It's saying that if any scalar is summing in any row or column, then we can separate as like here, because C1, C2, C3 is summing in the third row, so we can separate here. Okay, first we write B1, B2, B3 and R1, R2 as it here, R1, R2 as it here, and in next we write C1, C2, C3 here. So this is the property of the determinant. So this is looks like what? This is looks like A1, A2, A3 and B1, B2, B3. This is vector A cross vector B. This is vector A cross vector B. Okay, and this is right as what? Be solving the you get vector A cross vector B, and plus here this is what? And right first component, this is component of vector A, and here the component of vector C. This is a vector A cross vector C. Okay, so this is a vector A cross vector C. So it is equal to what? It is equal to this. So we finally say that this is equal to what? RHS. So this implies what? This is LHS equal to RHS. I hope it is clear to you. So we write as what? Vector A cross vector B plus vector C is equal to vector A cross vector B plus vector A cross vector C. So this is proof. This is proof of the statement. So hence proof. I hope it is clear to you. Coming to the next. Here, if either vector A 0 vector R vector B equal to then vector A cross B vector B is the converse to justify our answer. Saying that we know that modulus of vector A cross vector B is equal to no, taking here not modulus. This is what vector A cross vector B by definition of the cross product of two vector modulus of vector A modulus of vector B sin theta n cap, where n cap the perpendicular unit vector perpendicular to vector A and B, unit vector perpendicular to vector A and vector B. Okay, if we is saying vector A equal to 0 vector, so modulus of vector A equal to 0, so it becomes vector A cross B equal to 0. If either R, if vector B equal to 0, so its modulus of vector B equal to 0. If using in this, it becomes vector A cross vector B. So it reverse is what? It reverse is saying that reverse converse. What is converse of this? Converse of this, if converse of this, if vector A cross vector B equal to 0. So we say that this is either vector A or vector B. So this is either vector A 0 or vector B 0. This is true or false. This is converse is true. No, this is not true. This is what? No. Answer is what? Is the converse true? No. It is false. It is false. Why? So taking the example here, like I cap cross I cap, it becomes what? Making angle 0 degree with itself, so becomes vector 0. And you see that vector A, this is I cap not equal to vector 0, and vector B, this is also I cap and this is also not making not a 0 vector. So here you see that, so why I cap cross I cap becomes vector 0. Here this is example here. I hope it is clear. So this is converse true, this is no, false, it is false. Okay, so converse true, not no, answer is no here. And example is taking as you take any two equal vectors or any two collinear vectors. Okay, if you're taking any collinear vectors, it also satisfied. I hope it is clear to you. So coming to the next questions. Find the area of triangle with the vertices here. So solution is what? Saying that this is a triangle A, B and C, and this is a 1 1 2 its position, and B position is what? 2 3 5, and C position is what? 1 5 5. Okay, so what is position vector of OA? So vector OA is equal to what? Position vector of point A, what? I cap plus 2j cap. I hope it is clear to you. If you not watch my previous lecture how to find position of any point, position vector of any point, please watch it. And vector OB equal to what? Just taking the I cap j cap here, so 2i cap plus 3j cap plus 5k cap. Okay, and vector OC what? Position vector of point C. So this is I cap 1 here plus 5j cap plus 5k cap here. Okay, so area of triangle ABC what? Area of triangle ABC by using 1 by 2 modulus of vector AB cross vector AC, taking any two adjacent side, like AB here, this is AB and this is AC, this is AB and AC adjacent side. We also taking the BC and BA because this is also adjacent. We taking CA or CB. So we taking any two sides of the triangle as like that. So finding AB what? So what is vector AB? We need to find vector AB. So taking the vector AB, this is vector OB, and here we solve position of vector B minus. We first write vector OB minus vector OA. Okay, so write is here OB minus OA what? 2i minus I cap becomes what? This is what? On j cap. Here this is 2k cap. Okay, so writing here OB minus OA, 2i cap minus I cap, this is I cap, 3j cap minus plus j cap, it becomes 2j cap. Okay, and this 5k cap minus 2k cap, this is 3k cap. and this is what? Vector AC. Vector AC is what? Vector OC minus vector OA. Okay, OC minus OA. First write C, then A. Okay, so this is what? OC minus OA. So OC minus OA. This is I cap minus I cap becomes 0 I cap, and 5j cap minus j cap becomes 4j cap, and 5k cap minus 2k cap becomes 3k cap. Simplify it. So what is vector AB cross vector AC? Simplify it. AB cross AC, be taking the I cap, j cap, k cap, and this is component. Vector AB component is 1, 2, 3, and vector AC component is about 0, 4, 3. So simplifying it. So simplifying like plus minus plus along R1. So AB cross AC we get AB cross AC. You get what? I cap, and removing first row and first column, 2 3 are 6 minus 4 3 are 12, minus of j cap, removing second row column and first row, you get 3 into 1 3 and 0 into 3 0. This is a plus k cap. Here this is removing third row third column and first row, you get 4 into 1 4 0 into 0. Simplifying it, you get this here. So AB cross ACB, what we get? AB cross ACB get, so what? 6 minus 12, this is minus 6 I cap, and minus 3j cap, and plus 4k cap. So taking its modulus of vector AB cross vector AC is what? This is equal to under root minus 6 whole square minus 3 whole square plus 4 whole square. Simplifying it, you get vector AB cross vector AC is equal to under root minus 6 whole square 36 minus 3 whole square plus 9 and 4 whole square 16. You get this. So AB cross AC, you get, adding this you get what? 36 and 9 becomes 45, and 6 51 under root 61. Okay, this is 36 plus 9 45, 6 51 and 61. This is under root 61. So area of triangle ABC what? Half of modulus of vector AB cross vector AC. So adding the slide next. So area of triangle ABC what? So area of triangle ABC is equal to half modulus of AB cross AC. So this is half under root 61. So under root 61 by 2 square units area of this triangle. So this is our answer. Okay, I hope it is clear too. This is our answer. So coming to the next question. Find the area of parallelogram whose adjacent sides are determined by the vector. So you know that solution is what? You know that area of parallelogram is equal to modulus of vector A cross B, whose adjacent sides are vector A and vector B. So we simplifying here. So taking the modulus of vector A, first we write vector A cross vector B here. So vector A cross vector B here. So I cap, j cap and k cap. I cap coefficient is what? 1 minus 1 and 3, and B cap coefficient what? Vector B component 2 minus 7 and 1. Simplifying it, this is 1 minus 1 and 3, 2 minus 7 and 1. Simplifying it, this is plus minus plus. Simplifying it, this is I cap, and removing first row first column, you get 1 into minus 1 minus 1, 3 into minus 7 minus 21 plus 21. Okay, along R1 we can simplify it. This is minus j cap, and removing second column first row, you get 1 into 1 1, 2 3 are 6, and this is a plus k cap. You simplifying it, and removing third column and first row, you get minus 7 into 1 minus 7, and 2 into minus 1 minus 2, and taking minus s becomes plus 2. Simplifying it, vector A cross vector B you get. So this is minus 21 minus 1 becomes 20 I cap, and 1 minus 7 becomes minus 5, and minus minus plus here plus 5 j cap, and here minus 7 plus 2 minus 5 plus minus minus, this is 5 k cap here. And taking the modulus of this, modulus of vector A cross B what? You get this 20 whole square plus 5 whole square plus minus 5 whole square. Is simplifying it. and 20 whole square becomes 400, 5 whole square becomes 25, minus 5 whole square becomes 25. It becomes under root 450, and simplifying it you get what? Vector A cross vector B, it can be written as 9 into 25 into 2. Okay, if this is under root 9 becomes 3, under root 5 becomes 5, and this is under root 2. Okay, so we write as here, this is a 15 root 2. Okay, so area of what? Therefore area of parallelogram is equal to modulus of vector A cross B. Here A and B are adjacent sides of the parallelogram. So this is what? 15 root 2 is square units. This area, because area is square units. So 15 root 2 is square. This is our answer. This is important for you. Practice then for this. Okay. It has weighted 5 to 4 marks. So coming to the next questions. And next question is what? Saying that this is a MCQ type questions here, saying that vector A cross B is unit vector. So this is a unit vector. It means that modulus of vector A cross B is equal to 1, and we know that modulus of vector A cross B is equal to what? If theta be the angle between them, vector A and B, then modulus of vector A, modulus of vector B, sin theta. So simplifying here, so modulus of vector A, because this is a unit vector, so modulus equal to what? 1. So modulus of vector A, modulus of vector B, and sin theta. So this is what? Because this is unit vector, and taking the modulus of vector A, what? This is the 3. Modulus of vector B, what? Under root 2 by 3, and this is the sine of theta is equal to 1. And theta with the equate angle, saying that theta is the equate angle means we need to find the equate angle from the options here. So 3 cancel out. So sin theta becomes what? 1 by root 2, and this is equal to what? Sin pi by 4. So sin theta equal to what? Sin pi by 4. So theta is equal to what? Pi by 4. Taking the sine inverse both the side, you get theta equal to pi by 4. Okay, so this is what? Option number B will be correct. I hope it is clear to you. So coming to the next questions. Next question is what? If triangle ABC, if the quadrilateral ABCD is rectangle, here ABCD is rectangle, looks like here. So this is a point A, and this is a point B, and this is a point C, and this is a point D. We need not to perform the vector product here. So we here saying that position of A, B, C, and D are here. So position of A is here. So we write as simply coefficient of I cap, J cap, K cap. It's order triad. Okay, here. So this is minus 1 here. This is 1 by 2, and this is what? 4. Okay, and what is B? And B position vector is here. This is I cap coefficient 1, and B cap coefficient 1 by 2, and C K cap coefficient 4. So this is 1, 2, 4. And what is C? C component what? 1 minus 1 by 2, 4. I cap coefficient 1, J cap coefficient minus 1 by 2, and the K cap coefficient what? 4. And where here D is here. This is a component of I cap minus 1, minus 1 by 2, and 4. And this is a rectangle. So area of rectangle ABCD what? Area of rectangle ABCD what? Simply length into breadth. Simply AB into CD. Okay, so just simplify AB. This is distance between 2 points. How to find it? X2 minus X1. So this is 1 minus 1. 1 minus of minus 1 becomes plus 1. 1 minus 1 whole square plus. Okay, and 1 by 2 minus 1 by 2 whole square. 1 by 2 minus 1 by 2. This is x1 y1 here. This is x2 y2. 1 by 2 minus 1 by 2 whole square. This is 4 minus 4 whole square. This is a 4 minus 4 whole square. Okay, simplifying it. This is x1 y1 z1. Writing as x1 y1 z1 and solving AB. This is x2 y2 z2 here. So simplifying it here. So you get what? 1 plus 1. This is 4. And 1 by 2, this is 0, and this is 4 minus 4, this is 0 square. This is under root 4 becomes 2 units. AB is equal to what? 2 units. Then CD is equal to what? Also 2 units, because this is rectangle, this is also 2 units. Just simplifying, you need to find AD. So AD is what? This is under root x2 minus x1 whole square. So this is minus 1 whole square. It becomes minus 1 plus 1 whole square becomes 0. And this is minus 1 by 2 whole square minus 1 by 2 minus 1 by 2 whole square, and this is what, 4 minus 4 whole square, 4 minus 4 whole square. Simplifying it, and simplifying you get minus 1 plus 1 whole square, 0 whole square, minus 1 by 2 minus 1 by 2. If you solve minus 1 by 2 here, like minus 1 by 2 minus 1 by 2, you get minus 2 by 2, you get minus 1. So minus 1 whole square becomes plus 1 here, and 0 minus 4 minus 4, 0 whole square becomes 0. This is under root 1, this is 1 units here. So AD is equal to what, 1 units, this is 1 units, okay, and this BC is also 1 unit because this is a rectangle. So we need to find area of this. So AB is equal to what, AB is equal, if AD equal to 1, then CD is equal to what, sorry, AB equal to what, AB into, not AB into not CD, AB into AD here. Okay, this is area of this, AB into AD. I hope it is clear to you. This is 2 units. Okay, so AB equal to what, we get AB equal to 2 units and AD equal to what, 1 unit, 2 into, because this is a rectangle, this is 2 square units, this is 2 square units. Which option is here? Option number C will be correct, because C is the 2 units here. Okay, in square units he is saying that. I hope it is clear to you. This is all about the exercise 10.4. okay, if you like my content, then subscribe my channel and share among your friends, and also press the bell icon so that it will receive notification on time whenever I upload my video. If you want to miscellaneous of this exercise, vector algebra, please comment in comment box. Thank you. Jai Hind.